In this video, we're going to be looking at more advanced questions on compound inequalities. Now, if you notice the previous questions that we have been working thus far, the variable was only in the middle here, okay, between the two inequality signs. However, if we look carefully, we have a variable on the left hand side also and on the right hand side. However, the same principles apply, okay. So let's look at it quickly. Now, as I've stated, when working with compound inequalities with two inequality signs, what I'm going to do, I'm going to open my bracket, okay, and I'm going to go across the first inequality sign and I'm going to stop where the second one begins, and I'm putting that in a bracket, and we're going to calculate this now, okay, quickly. Sorry, so I can say this is 3p minus 7 is less than 6p plus 2. Now, it's the same way we're going to manipulate this. I'm just going to say, when I look at my 3p, I notice I have less, because the objective is to keep the p on the right hand side. When working with this side, I am going to take the smaller amount of p's to my right to calculate it. Hence, I will keep my p positive, okay, rather than to bring in a 6p over here and it will become negative. Okay, guys, now it can work, but just to make it a lot easier for you, I would bring the smaller amount of p's to the inside. Okay, good. So let's move our 3p first. So I'm going to say, since 3p is positive, I must subtract 3p from both sides of my inequality, minus 7, and that must be less than 6p minus 3p, because we had subtracted 3p here, plus 2. Okay, now I know that 3p will cancel out with 3p, so I have a negative 7. Negative 7 is less than 6p minus 3p will leave me with a 3p plus 2. Now my next step is to take my positive 2 to this side of the inequality. So since it's positive, I must subtract 2 from both sides of my inequality. So I'm going to have a minus 7 and I'm going to minus 2 is less than 3p plus 2 minus 2. So I know that this negative 2 will cancel out with the positive 2. So here now I will have negative 7 minus 2. That will give me a negative 9, and that is less than 3p. 3p. Now I need my p alone to be in here. So 3 is multiplying p. So I must now divide through to get to isolate the p on the right hand side here of my inequality. So we're dividing through by 3. So 3 will cancel 3, and 3 into itself goes one time, and 3 into negative 9, I would get a negative 3. So my solution set here is negative 3 is less than p. Okay, so that's one side we have worked. Let's look at the other side. So again, if you notice what I'm doing carefully, I'm just going to put this in a bracket, start here, and I'm coming across the first inequality sign, and I'm going to stop exactly where the next one would begin. So I'm going to stop right there. Okay, and remember, the type of brackets that I'm using, it has no significance. It's just used to distinguish the different parts of the inequality that I'm working respectively. Okay, good. Now here I will have a 6p again, because I'm working what is in the blue now, the part of the inequality in the blue. So I'll have a 6p plus 2 is less than or equal to 3p plus 23. Now again, since I have my p's here and this is a 6p is more than 3p, so I'll take the less amount of p's to the inside. Okay, so I'm going to, since this is positive, I'm going to subtract 6p from both sides. Sorry, 3p from both sides. So I'll have 6p minus 3p plus 2, and that is less than or equal to 3p minus 3p plus 23. Now I have a 3p cancelling out a 3p, and 6p minus 3p, that will leave me with 3p. Plus 2 is less than or equal to, and I have only here a positive 23. Now, since I have a positive 2 being added to 3p, I must get rid of that 2 and bring it to this side. So I must do the opposite of addition, which is subtraction. So I'm going to say 3p plus 2, that's my statement here, minus 2 now is less than or equal to 23. And since I've subtracted 2 there, I must subtract it here. So I know that positive 2 will cancel out with a negative 2. So really I'm left with 3p is less than or equal to 23 minus 2. That will leave me with 21. However, I need my p alone here. So to isolate my p, when I look at it, 3 is multiplying p. So I must divide through by 3. Okay, which is the opposite of multiplication. So I'm going to 3 will cancel 3. So I'm left with p is less than or equal to 3 into itself goes once, and 3 into 21 goes 7 times. So p is less than or equal to 7. Now, as I said, here is the neat little trick that you should be comfortable with by now. Okay, let me pull up this a bit. Now here what I'll be doing, I am just going to bring these two stuff together. Let me use a nice color. So I'm going to change that. So I'm just going to, now I have my solution here and I have another solution set, but since it's compounded, I'm going to pull them together now. So I'm pulling this inside here now, okay, and I'm going to pull this solution set inside there also. So this p here, I'm going to write p. This p will replace these two p's as we have stated, and here now what I have, let me use that color, I have p in this case is greater than negative 3, but in this case I have p is less than or equal to 7. Okay, so this now guys, this that we have here is it's our solution set. Good. So let me just put it in a rectangular box to indicate that. Now, as I've said, we can be asked to show this on a number line, or we can be asked, let me just pull up that a bit, we can be asked to show it on a number line, or we can be asked to write it in interval notation. So yes, so to write this in interval notation, all we're doing, I am looking at my inequality sign here and I have a less than sign. Okay, so here I'm going, my boundaries are negative 3, so let me write them, negative 3 comma 7. So you always write your boundaries, but when I look at this inequality sign, it's a less than. So once I'm using my less than sign, it simply means then I must use my parenthesis. Okay, because that is saying that negative 3 is not included in the set. But once I'm using a less than or equal to sign, I must use my braces. Okay, so that's it. That's it in interval notation. Now to represent this on a number line, again, our boundary is negative 3, so let me start at, I can start at negative 4. So I would have a negative 3 there, negative 2, negative 1, then I would have 0, and that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so that's my number line. So again, quickly, let's get this out. My boundary is negative 3, so I'm going to put a circle over my boundary, negative 3, and my next boundary is 7. So I'm going to put a circle above 7. Now I'm going to look at the signs here. This is a parenthesis. So once I'm using a parenthesis, this circle must be open. But once I'm using my braces, this circle must be closed. Okay, so let's close that. And then from there, all you're doing, I'm using my ruler to connect my two endpoints. Okay, so you use your ruler and you just draw your endpoints, and that's how we represent that on a number line. Okay. All right. If you have any questions or comments, feel free to post them and I'll get back to you as soon as possible. Bye bye.